ladies and gentlemen, hello and welcome back once again to the briefing room. Yes, indeed, it is Tuesday at 4 o'clock Eastern, which means it's time for the show that is designed to really get down to the nuts and bolts and understand what these enterprise technologies do and how they can work, and especially how they can work for you. And the topic for today, well, let's just say it's big, folks. Yes, indeed, there's a slide about yours truly and enough about me. As many of you now know, the mission here in the briefing room is to reveal the essential characteristics of enterprise software, good and bad. And I really like the title of today's episode. We're going to talk about Hadoop, what it is and what it's not. And I can tell you one of the best things you can ever hear from a software salesperson or any software person who is, hold on one second, any software person who is working in the field and talking to you, one of the best things you can hear is when they tell you what their software does not do. That's the key. If they tell you what it does, well, that's useful, but if they tell you what it doesn't do, that means they're honest brokers, and that's a really good thing to have in your pocket, folks, when you're trying to buy these technologies, because they're not cheap, as we all know. So October is Database Month, and it's interesting. We're going to talk about Hadoop today, and it's not technically a database. It kind of is. It acts like a database. There are lots of things around it that can help it act like a regular database. We'll probably get into some of that stuff. So, but the question is, does Hadoop constitute a data warehouse? It's a big question that's been circulating out there for the last couple of years, and of course we are all talking about big data just about all the time these days. It is one of the biggest hype cycles I've ever seen. But the bottom line is that when you get big vendors like SAP and Teradata and IBM all talking about integrating Hadoop, you know that it's real. As the old expression says, there can't be that much smoke without some fire. So obviously there is some fire to this stuff. We're going to find out what Hadoop is underneath the covers, how it works, and really try to explain a good way to use Hadoop. And one of the real keys is that it needs to be viewed as an augmentation to a data warehouse. Now, it may be sometime in the future some other open source projects get woven around Hadoop to make it more like a traditional data warehouse, but my guess is that's probably not going to happen, or if it does, it won't be in the same way that the traditional data warehousing world has evolved, and the architecture will be a little bit different. But we'll get into all that fun stuff. And a quick reminder, don't be shy. Please do ask us some questions. So we're very pleased to have analyst Mark Madsen back from his European tour. 5 conferences in 2 weeks is what I heard, which is just amazing. So hopefully he's gotten over his jet lag. And the vendor in our show today is Hortonworks. This is a very interesting vendor. I love all of their symbolism. I love the elephants. Of course, they're playing around those same kind of themes that you see in the Hadoop world. So Hortonworks is an enterprise software company that focuses on the development and support of Apache Hadoop. We're probably going to hear about committers today. We're probably going to hear about the community. And of course, as many of you know in this industry, open source is just, it's everywhere these days. It arguably started with Linux and our friend Linus Torvalds, who got frustrated with a certain operating system called Windows, or I don't remember if it was called Windows way back when it first came out. But let's face it, he was upset about that and frustrated and said, you know what, we're just going to build our own operating system. And now, thanks in part to $1 billion or more of investment by IBM, Linux is a robust operating system that is enterprise ready. It's all over the place. Just about every major enterprise software vendor in our space writes for Linux. So open source is solid, and it is a solid framework, and these are other open source projects we're going to talk about today, like Apache Hadoop. So there is Jim Walker, formerly of Talend. Now he's over at Hortonworks, and he's living in the Bay Area, I'm told. And as the kids in the Bay Area would say, that look he's got right there is, in fact, crescent fresh. So yes, indeed, with that, I'm going to hand it over to Jim. I'm going to give you the keys to the WebEx. If you just click anywhere on that slide and use the down arrow, you can go through your slides, and we can find out what Hadoop is and what it's not. It's all you.
Thank you very much, Eric. I'm happy to be here today with everybody. Yeah, we're going to do a little bit about what it is and what it isn't around Apache Hadoop. And really kind of, I wanted to focus a little bit on, trying to make it useful in terms of how it can be used in an organization and why it's being used in an organization. I am going to touch on a lot of the things that Eric spoke about, up front, and I thank you for the kind introduction, Eric. I'm not sure what your crescent fresh means or not, but I'm going to go with it, okay? So
find out.
So with that, I think, to really kind of set forth, and set a baseline, right? There's this term big data. And, when I was first introduced to Hadoop about 2 years ago, 2.5 years ago, the concepts of volume, velocity, and variety were put in front of me as kind of definitions. And I feel that they're great definitions. They're characteristics of what the data is, really, quite honestly, and they're fairly technical. What we've noticed with our customers as we've worked with them is that, big data is about transactions, interactions, and observations. I feel that this definition gives it more context in terms of what it's doing in your organization. And when I think of transactions, I think of all our old ERP data, right? I think of purchase details and records. When I think of interactions, I think of CRM. I think of web, social media kind of stuff, looking at web logs, or just being able to butt that traffic up with your CRM database, say your Salesforce.com or whatever system you're using for a CRM, right? And that's kind of interactions. And then there's these observations. I think observations are kind of interesting because there's a lot of data that we've thought of before as kind of low to medium value data, or quite honestly, we thought of it as exhaust data, data we just threw away and never used, right? And so, big data kind of encapsulates all these different things. When I start to think about some of these newer sources, we think about, RFID or sensor data, these sort of things, it's like that Progressive commercial where they're putting that little thing in your car, that girl in that commercial, and they're collecting all this data to give you a better rate. That's a bunch of sensor data. Every car has a computer in it. If we think about RFID and what they're doing in, say, hospitals, monitoring, tracking patients via RFID, or even better yet, physicians, to make sure that they're standing and washing their hands for 30 seconds before they move on to the next room so they can combat disease, right? These are all big data initiatives, right? And these are all kind of being enabled by having an understanding of who employees are, or who patients are, or who customers are, which is all that data, but all the sensor and kind of new sets of data, new things that we haven't been able to deal with before. So I feel that the definition of volume, velocity, and variety are great. But I think in a more realistic term, what these things are is transactions, interactions, and observations. And we think all those things kind of do come together to form what is big data. And we're talking about big data, and companies are turning to these technologies because they want to become data-driven. Data-driven just means you're using data in all your decision-making process, and we do that every day anyway, naturally, but being more regimented about it, right, and being organized around it, right? Tying these things to KPIs is ultimately important. When I think about the ultimate and data-driven business, and the easiest way that I could explain this to, I explain things to my father all the time. I say, Dad, did you ever see that movie Moneyball? That's a great example of a business becoming a data-driven business, right? And in becoming a data-driven business, not only do they have, wild expectations and wild outcomes, right, but they transform the industry. And I feel there's a lot of likeness in terms of what's happening today with big data that we could see in that movie. It is starting to transform the way that other organizations are thinking. At the end of the movie, Billy Bean is recruited by Boston. Thank God he didn't go there, but that's another story. They still adopted the data-driven model, right? So data-driven business is really kind of, I think where a lot of organizations today want to be and want to drive in that direction. So why are they doing these things, right? And so baseball, it's about optimizing the outcome, and that would be the World Series, right? But within each vertical, there's different metrics that we measure, right? And it's really about, measuring and optimizing these outcomes at scale. Jeffrey Moore, who's a fantastic author, he wrote this book called Crossing the Chasm. If you haven't read it, it's fantastic. He spoke at our keynote at Hadoop Summit last summer, and he gave a really wonderful presentation about where Hadoop is and how it does help optimize outcomes at scale. If anybody's interested, hortonworks.com/more, M-O-O-R-E. There's a full recording of his presentation. It's really fantastic. But this is a little bit of why organizations are going through this, right? It's all about optimizing. So what are they doing, right? When we think about big data, we think about flows of big data in the organization. Well, over on the right-hand side, we have these kind of two worlds, right? We have business transactions and interactions, all my CRM, my ERP, my mobile, my point-of-sale systems, right? It's up and over to the right. Right below that, we have, analytics and intelligence, right? These are, all my BI tools, my visualization, these sort of things, all the reporting, the things that help me run and steer my business, right? We're kind of like operations and intelligence and analysis, right? So, we can do a lot of classic data integration and ETL between these systems, to help them, yeah? Well, along comes these new sets of data sources, which we look at them way over on the left-hand side, you know, unstructured data, log files, exhaust data again, you know, all my social media data, right, sensors, devices, and traditional database data, CRM, ERP, these sort of things, right? They all feed in. One note on unstructured content. You know, a lot of people speak about Hadoop and big data and, oh, it's this great unstructured data, right? And yes, okay, there is a lot of unstructured data that's involved. I think unstructured gets a little bit more attention than necessary, or because ultimately we're going to parse data so that we can put it into some sort of analytical process. We're going to put structure around results so we can feed it into business intelligence, right? So eventually, as it flows through the platform, we're going to do that, right? The cool thing about Hadoop in particular is that I don't need structure up front, right? And this is the kind of thing that twists the DBA's head, right? Because the DBA is like, great, I have to define the schema and use my DML to get the DDL all going and everything sorted out, and then I can push data into my database, right? Well, with Hadoop, we don't care, right? We're just pushing data into it, and we're gonna place structure on top of data later, right? And so that's a big difference between, you know, kind of the traditional relational world and this kind of big data in the Hadoop world, right? So what we do is we load the big data platform with a lot of data, capture all this data, right? And I can capture, you know, years of data as opposed to, say, you know, 1 month or 2 months. You know, we are working with a customer. They're in, you know, they serve up data to large organizations across telecom and healthcare and finance. And, you know, they were tracking data over about 3 months. And what they were doing is they were taking about 5% of data that was flowing over these networks and tracking about 3 months of that data, right? And so they were able to bill and do some analysis on this data to provide it to their end customers. That's what they were able to do today. Well, what they've done with Hadoop is they've now accelerated and are now storing even more data. They're capturing more. They're capturing 100% of data over the course of an entire year. So when you start to make the difference between 5% of data over 3 months versus 100% of data over the course of a year, that's a radical difference. And in terms of the analysis and the quality of intelligence we can pull out of that data, it's huge, right? And so we're able to capture a lot more data. And they're using Hadoop and the big data platform to process the data, parse it, transform it, refine it, aggregate it, and then distribute the results into my end systems. And then all the while, make sure that we have a feedback loop into Hadoop or the big data platform to make sure that, you know, results and whatnot are coming back into this whole flow. So, you know, a little bit about, you know, what it is, why people are doing it, you know, how it works, and then why, and the requirements around a platform, right? So really we need to capture, process, and exchange data. Capture as much as we can, collect data from all sources, process that data efficiently in a system that's, you know, a clustered system, which is Hadoop, and then be able to deliver that to my existing systems. Quite honestly, if I'm a CTO, I'm not going to go out and buy a whole bunch of new applications, right? I want Hadoop to just work with what I have today, right? I don't want to have to go out and purchase a bunch of new tools and retrain people, right? So make sure that Hadoop is going to be able, or the data platform, I'm sorry, excuse me, is going to be able to work with what you have today. And then one of the things that's, you know, often overlooked until people get a little bit further down the path of kind of implementing big data in Hadoop is operations, right? IT operations is absolutely important, right? So if you're going to have a cluster or a data platform, it needs to be managed, it needs to be monitored, right? I need to be able to understand the health of my cluster. I need to be able to provision new nodes or retract nodes from that. I need to be able to provide high availability and failover, right? These things need to be enterprise grade and able to meet the requirements of a mission critical environment. And then, of course, deployed in a whole bunch of different ways, be it cloud, on-prem, off-prem, you know, as an appliance, as, you know, virtualized, and then across all operating systems. I don't care if you're Linux or Windows, right? And so, you know, we're going to have to address all these needs in the enterprise, and that's really the requirements of a data platform for big data, right? So Hadoop comes along as kind of, you know, meeting all these requirements. And, you know, Hadoop has been around since 2004, 2005, right? Started with a group of engineers in Yahoo. You know, actually, Eric said I would talk about some of the committers. You know, our company was started when 24 of the original team of Hadoop came out of Yahoo and formed Hortonworks. We've collected a vast majority of committers from the Apache Hadoop community who are now working as Hortonworkers. And so, you know, I like to think that our developers kind of work for the community more than they work for us, because we are actually 100% open source. Every line of code those guys write goes back into the community, right? So, and what they've developed is Apache Hadoop, and it allows you to capture, process, exchange, and then operate this overall platform. So, over the course of the past, couple months and year, we've dealt with a lot of customers, and we're seeing people be very, very successful with Hadoop and identifying new opportunities or uncovering, operational efficiencies and this sort of thing. What it comes down to, and everybody has their own business problem they're trying to accomplish, what we've done is we've kind of identified there's 3 use case patterns, right? And so I love patterns of use. If you're an old developer, there's a book by Eric Gamma et al., a bunch of guys who wrote it, and it's all about, patterns of use, design patterns for object-oriented programming. The best book I had ever read as a developer. And so what we're trying to do here is kind of provide these patterns of use for Hadoop as well, right? And so we really kind of distill it down into 3, refine, explore, and enrich. I'm going to go through each one of them and kind of give you some examples of how people are dealing with these things, right? So the data refinery is the first concept. And, I like to think of big data as kind of the new crude oil, right? I could take data in, put it into this refinery, process it, and I'm going to pull out, say, petroleum, or I'm going to pull out diesel, I'm going to pull out plastic, right? It depends on how I process that data. But I know what the algorithm is up front, right? I'm going to put it through some sort of process. I know what I'm going to expect at the end, and that's exactly what I'm going to get. It's great, right? And so really, Hadoop is being used in this way. It's kind of thought of as, the T in ETL. I think of it more as ELT. You're going to extract load, right, and then transform a little bit more. But you're going to go through and kind of do these things. And so you're going to take, maybe pick off a couple of processes that are, computationally intense, or do these transforms on data that you just weren't even able to deal with before, right? So capture as much of this data, parse it, cleanse it, apply structure and definition, join data across different sets, right, to get your outcome, right? But going into kind of this refined pattern, you already understand what you want coming out the other side. And I think that's a key differentiator between this pattern of use as opposed to the next one, right? So, if we look at the second pattern of use, it's exploration. And so, we hear the terms like data scientists, the business analytics guys are doing these sort of things. And what we're doing here is we're taking data, we're placing it into Hadoop, and then we're using tools to kind of process and deal with this data and kind of explore nuggets, right, within Hadoop itself, right? We find people using Pig and Hive, or writing native MapReduce, or using things like Talon to, sort or aggregate, or, go through these things. They're using things like Mahout, right, or Mahout, however you want to say, yeah? And they're using it kind of as an exploratory analysis platform. And often what we find is that organizations will do this. It's an agile kind of environment where they're doing this exploration, and they're finding these process or these patterns, or if you want to say it, an algorithm that they want to put data through, that they're going to have some sort of great value come out of that, right? They're exploring what they want to find in the big data. They're using visualization tools like Data Mirror or Tableau, these sort of things, right? And then they take that process and they say, great, let's operationalize that and use that outcome in the first use case, which was refine, right? So this use case is a little bit more tricky in that we're doing exploration. The first one was refine, where we're taking the output and applying that process, right? So these two are kind of related. And then really the third use case, let me just move on here, oops, excuse me, is enrich. And enrich is kind of interesting in that, we're taking data, we're taking results of data, and we're feeding them into a low latency or, easy to access database so that our front-end applications can have access to this stuff. It's one of the original use cases at Yahoo. How do we build a better homepage, right? How do I serve up better ads, right? So Yahoo, they're taking, the characteristics of their visitors over maybe 120, 130 different characteristics, and they're analyzing these things and saying, what's the right content that I could create, that I could put in front of this person when they visit the website? And it's not just about putting the right sports scores in front of them or the right news stories or shopping. It's about ad optimization, right? That's a huge deal, right? A huge moneymaker. If we think about recommendation engines, let's say in Amazon, or the way that Home Depot is going to put information in front of people, this is the sort of use case that is being used from an enriched point of view. We're enriching that online presence, or we're enriching that experience for a customer who's going to interact with me, say online or through some application, right? And so there's kind of the three use cases, right? We've got refine, right? I know my process, I'm putting it through, I've got that very kind of understood, right? Explore, where I'm exploring, I'm looking for data, I'm discovering new information. And then the third one is enrich. I'm using big data to enrich an experience, right, and make it better, right, because I have all these great results, right. So those are kind of the three usage patterns that we've seen around Hadoop. Now, Hadoop fits in a lot of different places within the organization, right? I mean, one of the first things we spoke about here today, I don't know if it was before we started today or in Eric's introduction, but, Hadoop has its place, okay? If you have a hammer, everything's not a nail, right? You've got to use Hadoop where it makes sense, right? And so ultimately, it fits in a lot of different ways. Does it replace the enterprise data warehouse? I don't believe so, because quite honestly, the EDW has a lot of great functionality in it. Can Hive serve as an EDW replacement? I guess in some situations, but there's a lot of advanced functions that companies have been built around that provide great value in those environments, right? Hadoop has the job of interacting with the EDW, providing better information into the EDW. Can my enterprise data warehouse have SQL-like access into Hadoop to pull data in real time or to look at results of an exploration process, right? So let's augment the systems that we have, really. So Hadoop is there to augment, really, my existing business infrastructure, right? It's there to enrich maybe my web applications. It's like the third use case. And then a lot of people are using new technologies on top of Hadoop, like the data mirrors, the Tableaus, these kind of guys, right? Chronosphere, Splunk, to actually use Hadoop to do things for it, right? A lot of people are, there's a huge increase in R and a lot of these analytics tools. They're using Hadoop as a back end because it's commodity hardware. It's inexpensive to store and process data, and you get some really great results. Ultimately, it's got to fit with operations as well. And again, I think, these are the poor guys who are tasked with making sure everything's up and running all the time, right? And so, big data and Hadoop has got to work within the context of all these different things. We like to think it sits in the middle of a lot of different things. Now, I want to go back to one other point I wanted to make sure that people are kind of familiar with, right? There's Apache Hadoop, which is the core technology. It's highlighted in blue here. It's MapReduce and HDFS. It's storage and processing, right? And that's the core of what it is. And then there's a Hadoop distribution. And a Hadoop distribution takes a lot of different packages around it and pulls it together. I like to think of it as like the Linux kernel and then a Linux distribution. The kernel is the kernel, and then there's all these things that go around it to make it useful and reliable and stable in the enterprise. And that's really what a Hadoop distribution does, right? So Hadoop is the core, but it's also a distribution as well. I think it's a key point to kind of differentiate. So no matter what business you're in, there's going to be a use case that, is going to affect, your particular line of business. I have, a lot of people that I deal with in a lot of different, verticals across the world. I have a really good friend who works for a large energy company, and one of the issues they have is about production versus consumption of energy. When we split the atom or we burn coal, there's no magical battery to hold all that energy. We've got to use it, right? And so the goal of the energy company is to get as close to that production curve as possible, or as close to the consumption curve as possible, right? It's difficult to do because we aren't getting data, quick enough, right? What if I'm able to take weather and, past historical usage and then maybe smart meters and take a whole bunch of data to get it together to start to get a better understanding of consumption? Could I get the production curve a lot closer to the consumption curve? I think so, and that's, so here's a very staunch conservative industry who's using big data to kind of change the way that they're moving forward, right? So no matter really what the vertical you're in, there's going to be a use case that is going to be applicable. When I think about retail and web and all the recommendation engine stuff, social graph analysis, lots of different use cases. We have a lot of information about this on our website. So in my last minute, the small commercial, right? We are an open source company. At Hortonworks, we fully believe that by the end of the year 2015, half the world's data will be processed by Apache Hadoop. And those are some big goals because of the rate at which the data we're creating is expanding is crazy, but getting half of that to be processed by Hadoop is a pretty large, audacious goal, but we believe in it. And in order to do so, we are trusted, open, and innovative. We are the core of Hadoop. We represent the community. We've assembled a large percentage of the committers to Apache Hadoop. We are the developers. We're the architects. We're the operators of Hadoop. We've done this in production across some of the largest clusters in the world. We're 100% open source. We don't believe in proprietary open source. every line of code that we create goes back into the community, and we also innovate. You know, we are on the leading forefront of Yarn, which is the next generation of Hadoop. You know, the projects we focus on are around high availability, and Bari, which is an open source management and monitoring, right? Our focus is really about innovating and making Hadoop ready for the enterprise, right? We believe it's enterprise ready and stable and ready for mission critical projects. And so what we create is the Hortonworks data platform. It encapsulates a bunch of different projects, allow you to simplify deployment. It provides you monitoring and management tools. It allows you to integrate Hadoop with the rest of your org. I talked about, you know, how do I integrate with my existing business intelligence tools? Well, we have a project called HCatalog that we ship. It gives you a SQL-like interface, some metadata, some schema on top of Hadoop. That's what people need, right, to make it work with what you have, because, again, you aren't just going to rip out the tools you have today. You've got to make it work with what you have, right? And so metadata services are really important. And high availability on a stable and a reliable version 1 of Hadoop, right? So really what we're after is really fostering the adoption of Hadoop within the enterprise. And, you know, today some of the largest organizations on the planet are starting to use Hadoop in these mission-critical environments, and they believe it is a trusted, stable environment to kind of build out their big data analytics and big data kind of strategy around. So with that, I'm going to turn it back over to Mark. I think that was, I'm sorry, I'm like slightly over 20 minutes, Mark, but there's a lot to talk about there.
That's okay. And Mark, I'm giving you the keys to the WebEx right now, so the floor is yours. All right. We can't hear you. Mark?
You there, Eric?
Yeah, there we are.
Are we good?
Now
okay. I'm just going to take 5 minutes just to give a quick perspective on where I'm coming from so that there's some idea of what the discussion then will be about. So I think, you know, when I look at sort of the phenomenon of things that are going on now with data and all of this big data craze, I kind of look at the underlying architecture shift in computing that's happened. And, you know, Grace Hopper, the woman who was really pioneering the whole idea of machine-independent programming languages and a lot of other things back in the 50s, you know, she was pushing for changing the way things work. And we've been building up computers for a long time, and finally over the past 10 years we've worked a lot more on building them out. You know, her quote about not trying to do everything on one box, but trying to create a team instead of a big ox. And so, you know, what we've ended up with today is of course, the Silicon Revolution, Moore's Law, all of these things that have really pushed us to having lots and lots of compute power, but it's spread through a lot of processors. It's not faster processors, it's more of them, which creates some interesting imbalances in hardware architectures. And when you have that level of imbalance, the only way that you can get some level of balance in the bottleneck areas, which would happen to be, to some extent, memory, much more so network, and even more so I/O operations, you lash together a bunch of machines. And so when you lash together a bunch of machines, you still have all that excess CPU capacity, but you have now aggregated the I/O bandwidth that you needed to process all of that data. And we dealt with a history of a lot of problems of software being designed under the assumption of a single machine image, a single operating system image, instead of being scattered across all these parallel platforms. And so most of them don't scale well. And most modern databases put out by the major vendors work great in an SMP that's a single node configuration with multiple processors, but they don't work well when you throw them up in the cloud, which is really just a bunch of virtualized machines, but could easily be physically discrete machines, but they are distributed. And so the design has shifted, and one of the things that drove a lot of Hadoop development and use was the simple fact of being able to do parallel programming, aggregating IOPS and CPUs and memory in a modern architecture in terms of the machine architecture. we've focused a lot on big part of big data, and I fished this out from a friend at Teradata because they talk about June 2 of 1986, which is when they shipped the first big system. And, when you think about a terabyte of data needing to wedge itself into a North American van lines truck, it gives you an idea of how technology's changed. But the simple fact that it was there and existed at the time, and we've progressed quite a lot since then in terms of data scale with just a plain old relational database. There are petabyte scale relational databases out there. And so big is probably the least interesting problem. But it comes to the fore when you're trying to do something other than just query and count and retrieve stuff. And querying, retrieving some simple things, summing them up, counting them, that stuff is usually single pass. Sometimes it's multi-pass across the data set. But when you have to process an entire data set using any kind of an iterative algorithm, which most optimization algorithms and most sorts of analytics and more advanced statistics are, they typically have really bad processing times because they're order n squared or order n cubed. And what that means is that the time is going to take longer as a square or cube of the amount of data, and that's where we start to run into some of the interesting performance problems, which causes you to have to break things out. Architecturally, we've been designed around a single central repository in a relational database on a single server. That's been the architecture for a data warehouse for a generation now. And the problem is that the data warehouse anymore doesn't have all of the data that people need. It's got all of the core important data, but it tends to be missing bits and pieces that are needed at the edge of the organization or are needed to do analysis work, particularly causal analysis, because that's not stuff you just report and monitor on. It's stuff you have to actually analyze, and you don't know whether it's important until you actually work through a problem. And so one of the common problems is needing all of this data, not having it, 6-month turnaround times to model it, get requirements, build ETL, load it into a system, build a metadata layer, and deliver the stuff back out. And so that tends to be a very common complaint. And the proposed solution, of course, has been back up the truck and dump it into Hadoop and analyze it, and all your problems are solved, which works for one-off problems, but when you start to saddle more than one thing at a time into the system, multiple uses of the same data, you run into the problem that Hadoop operates as MapReduce, which is parallel programming over a file system, which is essentially a file system. That is a system of files. There is no metadata. So there are projects out there now to work on some aspects of no schema and no metadata, because it turns out that those things are useful despite what programmers have been telling us. And so now we have this problem of possibly reverting back to some of the problems of a data warehouse with schema and fixing things into stone. So we have basically the potential with soft schema or no schema in a file system-based architecture, which gives you easier programming. It means you don't have to model things in advance. There's a lot that you can do, and you don't have to model it first, and that saves a lot of time. But the problem is when you want to productionize things, not having schema or not having at least some model of flexible schema can create some havoc. And of course, from an I/O perspective, much more efficient to retrieve things when you're just reading them in if you're not joining stuff. So all of that messy normalization sort of goes away in these file-based systems. But that assumes you're not updating anything. If you start to update things, then you have to write everything out as opposed to just writing out the bits that changed, which was part of the efficiencies of that. And so that leads to all of this discussion about switching from a database to Hadoop, which was some of the early proponents' push, but that's not really where we are today because that's just not practical. And as far as how people have been taking advantage of it, the proponents have all been following the pony strategy, which is that we're a web company or we're a new startup. We have all of this data. There's got to be some value in all this data that we collect. There's got to be a pony in that green field somewhere. Let's go find it. And so you rack up a bunch of servers, run Hadoop, and filter it out. Problem is that it's not like writing queries. You need a data scientist, and data scientists would be formerly analysts who have technical analytic skills, so mathy stuff, understand the business well enough to know where to find ponies, and of course have the programming chops to be able to code this stuff, because we're working on a very raw platform. This is not a tools-based environment at present. And so those people, by another name, would be called unicorns. And so that's kind of how I view the world at the moment. So I thought now we could start the conversation about Hortonworks and Hadoop and some of the is-not stuff. You ready for that?
Go for it.
Yeah, I'm great, Mark. I mean, you bring up a lot of good points in your presentation. The whole concept of metadata and schema has been an issue, and I think developers, while sometimes they say we don't need that, or I forget the way you characterize it, I think everybody does see the value in that, so I can't agree anymore. And I think there are tools being built out around the entire ecosystem, and let's let people use the tools they use today and not build out new ones as well, right? So, at least we can find a horse, not a unicorn, right?
Right. Yeah, I mean, that to me is one of these things about long-term use. One of the use cases that you brought up was ad hoc, the sort of ad hoc analysis. And I'd say in the popular press, at least, 90% of what I seem to read about is ad hoc analytics. The data scientist who goes off in a corner for a day or a week or a month and carves up some insights out of this big chunk of data. But
right.
that is, in many ways, that is the support for something that we never supported in the data warehouse, which was one-off analysis projects that have short turnaround, for which we can't spend 6 months modeling and building in the tools that we've got. But the
right.
question then is, what do we need to design, and what are you providing to help us in some of the kind of longer-term use, either to support that in an operational sense or to support integrating into the environment?
Yeah. Well, I think there's two things, Mark, right? So, it's funny. There's the popular press and what they're talking about, and they're right. I mean, there's a lot of data science going on. It seems to be a term that people have glommed onto. I'm not particularly sold on it. I would argue that 90% of the use cases that we're seeing in reality of Hadoop are the refined use case. I mean, they know what the process is. They know what they want to accomplish. They're using things like PIG, which abstracts MapReduce. It's fairly easy, fairly straightforward to learn, to build out scripts so that they can transform the data that they have already. We're taking, let's take healthcare, for example. I knew a hospital in Southern California. They have, 30 years of data that they have, housed on tape in a closet that they don't have access to, right? They simply want to have access to that data so they can provide better customer service to, the guy who's walking in off the street who's been, living in that neighborhood for 30 years. They don't have access to that data, right? So they're using Hadoop as a simple place to now just store this data. They still have their tape backup. They, create a nice small little JSON interface on top of it to provide access to it. It could be as simple as that, just providing access to data that was once, inaccessible, right? It's not always this data science kind of world that's going on, right? And so really the Hadoop environment and the ecosystem has kind of evolved over the past, I would say really over the past 2 or 3 years very rapidly. Alan Gates, who's a peer of mine here at Hortonworks, he took the metadata layer out of Hive and created a project called HCatalog. And, Mark, you're your understanding of MapReduce and the schema things is absolutely dead on. You know, when you write a MapReduce job, you actually have to code in the schema to the very beginning of it. That can't just reference off to the schema, right? And so I'm an old developer. Oh my God, that's painful, right? What we've done is we've made it so that MapReduce can now look off into something called hCatalog, which was the metadata layer of Hive, to retrieve a schema so that we can change schema once or we can manage the schema once, and that's just in MapReduce. Can I use that same schema across Pig and Hive and the other tools internally in Hadoop, in that world, right, in that distribution? And that's really enabling developers to kind of use this kind of more shared schema, right? So yeah, there's a lot more conversations around governance and these sort of things, but the utility is there now within Hadoop. But that also opens up the schema to the external sources. You know, so we have partners like Teradata who are building on top of hCatalog. They're building a product called SQLH. It's already out there and used, where they're able to use SQLH to, you know, have a SQL-like interface into Hadoop. So now you have, you know, the 50 or so pre-packaged analytic tools that come with, say, After data, and they're now using Hadoop as a back end to, you know, run those sort of, you know, those requests, right? They have SQL MapReduce. There's an ODBC connector that connects to classic Teradata, right? So I think, you know, organizations are understanding that they need to not build new tools on top of Hadoop. They need to enable the tools that we already have to work with Hadoop, right? Kind of Hadoop enabled, if you will. So I don't know if that answers explicitly your question, but that's kind of what we're seeing in the marketplace. A, it's a lot of the first use case that we're finding. It's not so much the science. It's an important one, and people are doing that. And then B, you know, hCatalog and metadata and schema, they are important. They are really important. And I think that's what's enabling the enterprise to adopt Hadoop wide scale.
Mm-hmm. Okay. And, you know, I mean, the thing about schema, just both from knowing what's in there, but also as a point of agreement about what the data is, doesn't some of that, though, kind of, based on flexible use cases, take the shine off of some of the speed of development? Or, I mean, were we being sold a bill of goods when people were saying, this is so much quicker to turn things around on?
Yeah.
Or is there something
you know, yeah, this does not remove that promise at all. Quite honestly, it provides it's basically, if you think about hCatalog or schema, it's a lens. It's a view into the data, if you will, right? It's one schema among many that I can apply across the files. Like you said, you know, it's a file, HDFS, it's a file system. It's a bunch of files. Do I have a view on top of that that's in the schema that I need to present to my external resource or to use within my particular job, right? So the data is still the data. The schema can be dynamic and change over time, or be dynamic to be used within different jobs. So we aren't requiring schema up front to load Hadoop, right? Because, again, unstructured. Throw the data in there, and let's deal with schema as part of the processing problem.
Right. That makes a lot more sense. I think that's one of the things that, you know, often doesn't get out. And my personal project use of some of these tools has been, I would say, more along the lines of what you said, which is refining and enriching data and then shoving it somewhere else. But one of the things related to that was the nature of the environment. We talk about integrating it into IT, and I see about half the time it gets integrated into a data group, you know, the data warehouse, BI, that sort of a group gets tasked with at least thinking about this stuff. And yet they do not have a lot of the skills. So where do you see the platform, you know, the Hadoop platform evolving, or where do you see it needing to evolve to kind of meet some sort of a tool-driven as opposed to a programmer-driven model for IT?
Yeah, I mean, it's a really great observation, Mark. You know, so typically these conversations are started with the data architect, right? The data team gets it, right? They want to deal with these things, but very quickly there's a business analyst that they work with that is defining what they want to do. And, there's two different ways in which Hadoop is evolving. A, we're allowing the analysts to use the tools they already have, which kind of I was talking about in my last answer. And I think that's going to enable a lot of kind of shortcuts of data science is what I think of it, right? So let's use the tools you already have to deal with those sort of things, right? And I think the tool vendors are changing as well, right? You have, the ETL guys are building, they're building solutions that will do these transforms in their systems or within, say, Hadoop. We have a pretty, decent relationship with all of them. I've used, in my past, I come from Talon. Talon will create a pig script for you that can be executed on Hadoop. I mean, that's fantastic. I don't need to know a line of code. I think I ran a webinar a couple months ago called Hadoop So Easy a Marketing Guy Can Do It. And it's true. I mean, I got to load a cluster or create a pig script fairly quickly. So there's people who are developing tools on top of it, and I think that's really key. The adoption of HCatalog and using your existing tools is going to be extremely important as well. The one area of integration is that I think often overlooked, quite honestly. There's the architect, there's the business analyst, and the third key here is the operations guy, right? Because you now have this cluster. Somebody has to be responsible for the thing up and running all the time, understanding the health of it. It's a key integration point as well, and I think you need to think about it kind of across all three people, right? Data warehouse or data architect, business analyst, and IT operations. I think are the three key players, and each of them are kind of have their set of tooling they already use, and we just want Hadoop to be working with all those sets of tools, quite honestly.
Mm-hmm. So if we've got this kind of built in, the original design or a lot of the refinery work that we talk about is a lot like ETL, and these ETL vendors, which is very batchy, as a design point. So how do you get towards the two sides, low latency, which would be the kind of interactive request style of work, or low latency in the truly low latency environment you talked about before, where you're trying to optimize something or give things to people in real time in a process?
Right. Well, I mean, I think you're going to use the right tool for the job. Hadoop is not the panacea for everything. It doesn't fit every use case. Now, can it deal with a lot of real-time issues? Absolutely. I mean, there's projects like Flume, which allow you to, stream, say, log files or data into Hadoop. Is it going to provide you kind of real-time access across certain data or processing? It's not really built for that, quite honestly. It's built for a bit more kind of bigger batch type deal. However, you're going to be able to use Hadoop to do batch type processing and feed that to a low latency database. It's the enrich use case that I had talked about, right? And so as part of a Hadoop distribution, you'll have things like HBase. We'll work with partners of ours like MongoDB or Cassandra and Couchbase and DataStax guys, right? And they're going to serve up the information from a low latency point of view. They aren't going to use those tools to do analytics, though, right? They aren't going to do the massive processing to aggregate and refine data and parallelize these kind of deeper algorithms, right? Because I think you're going to have to use the right tool for the right thing. And so is it the real-time analysis of data? I think there's things that are going on within the Hadoop community to enable those sort of things. A lot of people are talking about it. But today, it's the refine use case. It's the first use case that we talked about, Mark. And there's a lot of value in that use case alone to do a lot of work for quite some time. But, I mean, honestly, my honest opinion is use the right tool for the right job, quite honestly, yeah.
So if most of our use case, 80% of our use cases, refining it in some way and passing it down the line, whether it's a table of coefficients so that you can do a real-time calculation or some sort of more, static thing. You talk about integration with ETL vendors, but why, I guess, is one of the questions. If I've got this as a platform, doesn't that kind of obviate the need for some of these ETL tools?
No, I don't think so. I think it forces a specialization within certain parts of that world. I mean, ETL is a tool. I mean, they're pretty advanced. You know, these guys have been around for quite some time. There's some really great functionality in those tools. You know, when we talk about, you know, a job that takes 3 weeks to do the transform on from an ETL point of view, and if I could shrink that transform down to 3 days, well, you know, then maybe it makes a whole lot of sense, right? However, if there's a batch job that goes every night where it's taking a couple hours and I'm, you know, doing this transform, it's really reliable and fantastic, use it for that. Again, I think it depends on what you're trying to accomplish, and if the computational power across these kind of you know, in this massively parallel environment is going to give you some sort of benefit for that particular usage of that transform, then maybe Hadoop is the right tool for you. But again, it's going to come down to what the business case is and the business value you're trying to get out of whatever it is that you're trying to accomplish. Does that help, Mark?
Yeah.
I think it's a specialization more than anything. It doesn't obviate at all. I mean, I think it all works together. I think it's part of an overall data architecture, right? You're still going to have your certain tool. You know, I'm not going to, you know, I'm definitely not going to replace an OLTP with Hadoop. That's you know, it's not built for that, right? You know, transactional database is still a transactional database, right? And so, you know, I think you're going to use the right tool for the right thing. I think what it comes down to.
And so, you know, we get to one of your earlier slides where you talk about a platform and what you know, what you mean by that. And it sounds like the way that you've been describing things, you see what you're providing as a data processing platform, which I guess one of the questions then is, what is a data platform?
Yeah.
Because there are all of these different components or pieces, and what it sounds like you're describing is a component piece of the overall architecture rather than, you know, the platform, which, you know, the same data warehouse marketing has been billing that as a data platform, but obviously there's something missing there if people are talking about trying to augment or replace data warehouses. So, you know, how do you see, if we go back to how do you see this sort of fitting in, there are augmenting pieces, but there are overlaps and substitutions in play as well, aren't there?
Yeah, I mean, I think, again, I think it has its place. It doesn't replace everything, but it has its definite place within the enterprise architecture. And so, you know, the concept of a data platform really comes about because, you know, there's technology and then there's enterprise-ready technology. And to be ready for the enterprise, you know, a data platform needs to do certain things. I mean, there's certain requirements, right? I need to be able to, it's not just processing, right, Mark? It's capturing the data. How do I store massive amounts of data on commodity hardware and make it redundant and reliable, right? How do I then, you know, provide, you know, high-speed processing of this data? And then, you know, more importantly, how do I exchange it? How do I interact with not just analytics and intelligence, but all the applications I have, right? And so, you know, really a data platform should be kind of neutral in what it's going to deal with as well, which I think is kind of a nuance that's different. You know, the EDW was working really well with BI tools and, you know, that part of the world, right? And so, you know, Hadoop can work with a lot of different things, right? So a data platform kind of extends beyond just a single use out into many other uses, and that's really the concept of, you know, the exchange. You know, I had a slide that said capture, process, and exchange, right? But to be fully enterprise ready and mission critical, you got to be able to operate it. And, you know, it's absolutely critical to understand and take those things into consideration as you're using anything. I mean, you know, especially Hadoop, right? It's, you know, it's a cluster. It's you know, it's you know, hundreds or thousands of nodes or 5 nodes. You still need to be able to monitor and manage the health of that thing. What happens when 5 nodes go down? How do I provision 10 more? You know, these are all things that need to be taken care of. And when we think about the requirements overall of a platform, we feel that this kind of more holistic view of it really helps us really deliver and provide what is, enterprise-ready Hadoop to the market.
Yeah, one of the things that you had said earlier on when you talked about ETL and ELT that I think is kind of interesting that made a good description was just that ETL is like or it was a very narrow set of technologies that seems to do a lot of the same things that people are doing with Hadoop environments, but it's viewed as a pipe between two things. Whereas, and a database is the storage layer, and the ETL tool is the transformation layer. And what you've got in Hadoop, in the sort of overall wrapped-up offering with all of the other bits and pieces, is something that kind of does both jobs, stores the data and processes the data simultaneously, which was missing in the other two environments and led to a lot of the problems in it. Would you say that's a reasonably accurate statement?
Absolutely, Mark. I mean, bingo, dead on, right? It's why, remember the DI, the integration market, we started to think about things like ELT because people didn't want to have to move or deal with all that data. Let's just deal with it where it lives, right? And so, yeah, people, we haven't thought about that. Hadoop lets you think like that because, well, again, we're using commodity hardware, so it's not crazy expensive to store all this data either, right? And that's there's been a shift, really, and it's really kind of, Moore's Law combined with, the shift in the amount of data that we're creating that has kind of enabled this approach, quite honestly. And I think that's a fair assessment, Mark. It is a bit of a hybrid between, the storage and the processing, or the pipe, if you will. I think that's a decent way of looking at it.
Okay. And I guess one sort of last question, was related to your piece at the end there, talking about open source. And one of the questions that I think is fairly common is, does open source matter for this part of the stack, given that it's a piece that sits right in there and gets kind of cemented into your architecture and probably doesn't change? Well, right now it's an emerging technology, but over time you can imagine, just like a database, things mature and stabilize. So why do you think that being open source, being 100% open source, over being a commercial, strictly commercial offering is important?
I mean, quite honestly, it fuels adoption, Mark. And so, we believe in Hadoop. We believe in Hadoop as being that next generation data platform. And we also believe in open source, and that open source has a way of transforming markets and making things available. When we look at, A, one side, availability, B, the other side is innovation. Our developers are part of the overall Hadoop team. There is a world of developers out there who are creating extensions and, tuning Hadoop to be ready for the enterprise. When we think about things like high availability, our engineers worked on that, but there were a lot of other people out there in the ecosystem that built that. We look at projects like Apache Mbari. Mbari is a monitoring management tool, right? Completely open source. We have a lot of committers to that. We have, many people who are providing input into that particular project. So the rate at which you can innovate is key as well. But ultimately, when it comes down to, in a pure open source market, it's going to protect itself from fracturing. And fracturing will kind of slow the adoption of a technology, especially within open source. When we have, 4 different spurs of what the software should be, the enterprise is confused. They don't know which way to go with it, right? And it slows that adoption, right? And so in order for this stuff to be adopted and kind of truly be transformational, we feel that open source is absolutely critical to that. Now, there's a lot of benefits to the world in that as well, and that, well, here's a freely used, download it off our website today if you want, right? And that's a big use for, that's a big plus. We aren't going to charge you for, this isn't open core. That's not what we're doing here at Hortonworks. Everything we do is given away. And, our leadership is, we've been doing open source. Our CEO and president and VP of corporate strategy, these guys are all old Red Hat and JBoss and Spring Source, and it's just the open source model through and through for us. So we're believers, and I think it is kind of the wave of the future for a lot of different software.
Well, it looks like it's time for Q&A, so I'm going to have to hand the Q part back to Eric.
All right, thank you so much. A lot of great questions from you, Mark. I love the pink pony reference. We got a lot of good questions, so I'm just going to dive right in. We talked about different things that Hadoop is good for, and I think, Jim, you referenced some things that it's not good for. You mentioned transactional databases, for example, real-time. I guess Hadoop is really not good for. What are some other things that you've heard people say they think it's good for, but really it's not? What are some other things Hadoop is not?
I mean, those are the two, Eric. The real-time streaming thing, or real-time analysis. I'm taking in new data and I need to turn around something in 2 seconds because it's against these 4 million records or these 8 trillion records, whatever. That's not Hadoop. I mean, Hadoop is going to be more a batch across all that data and give you results, and then you use those in some sort of process, right? We can do streaming. We can take data in. I mean, there's a lot of real-time type capabilities. And I mean, it's that and the transactional. I mean, this is not, if you want an ACID system where you understand transactions and that sort of thing, it's not built for that, right? I mean, think about the inception of Hadoop, right? You go back to 2004, 2005, Eric Baltzweiler and Arun, a bunch of guys, Doug Cutting, a bunch of guys are sitting around, they're trying to figure out, how do we create a better search engine, right? I mean, it was originally created to say, hey, let's consume what was the equivalent of all the data on the internet and plug through that so we can do better index search, right? It combines storage and processing in a single platform, right? And that's really what it's good for, right? And that's the genesis of where it came from. And today, that's where it's great. Is it evolving? Yeah, and there'll be other places. But I think those are the only two that I see that, I mean, if somebody wanted to throw out another one, I can definitely kind of confirm or talk through it. But I mean, those are the two that I see.
Okay, so let me jump to another question here. We got a bunch of different, really, really good questions, some specific and some a bit more broad. Disaster recovery. Have you come across disaster recovery as a common use case for Hadoop?
As a use case, it's funny. We live in this world of being able to recover from a disaster for Hadoop. There's a lot of things that we do, right? The redundancy of the file system and how we can store data in triplicates so that you're never going to lose data. High availability on a stable version 1. Those are the kind of things. From a disaster recovery, today, Hadoop could be used as kind of a backup system, I guess, for systems that are out there. It provides today on version 1 an active passive failover for high availability. In version 2 of Hadoop, which is, we believe will be stable in GA somewhere in January. There was just another release of that today. It'll be passive failover for high availability in Hadoop. So, it's becoming, these are all requirements of the enterprise, and, the community has answered and has built out these functions so that, enterprise-ready Hadoop can be available, in the short term. So there's a lot of functions there for it today. I'm not sure about using it as a use case. I'd have to know a little bit more detail.
Okay, so let me throw this one out at you. This is a really good observation from one of our attendees. Can you offer any advice, or is there any place someone can go to find anything by the way of categories or folksonomies for unstructured information? In other words, places where you can go to get more insights on how to deal with very specific kinds of quote-unquote big data.
Yeah, I mean, there's, I think of all the sources of data, and, Mark, if you had any input here too, I don't know if you know of any either, but, there's a lot of, data repositories and data markets that are out there. I know, our partner Microsoft is building one out, and so, there's patterns in there. I mean, I don't think there's any one source for kind of taxonomies across this sort of data. I use Google for everything, so that's where I find pretty much everything from a restaurant to a taxonomy.
Okay, and here's a very go ahead, Mark.
Mark, did you?
Yeah. probably see the same thing. You know, the whole concept of taxonomies, ontologies, controlled vocabularies is starting to appear in some vertical industries where there's a need for organizations to communicate reliably, but I think we're a long way from more generic data taxonomies.
Okay, good. Let me throw, now this is a very good question, and maybe both of you can chime in on this. One of the attendees asks, what is the format of data once it is in Hadoop? How is, in other words, is there any transformation? For instance, if I had multiple Oracle tables to convert, would they end up as delimited text files or some other format?
It's whatever it is when you load it. So if it's a delimited file and that's what you load, that's what you load. It's a file. It is a file that sits on a hard drive somewhere. So whatever format that file was in, that's the format that it's in. It's your responsibility to apply that format when you're going to be manipulating that data. The beauty of Hadoop is there's no transform on the way in. There's no schema on the way in. It's on read that you want schema, right? So there's no schema on write. It's only on read. Did you want to add anything there, Mark? Or I mean, does that help efficiently answer that question?
That sounds like a reasonable answer.
Yeah, it's a flat file, and then I guess the question then becomes, when you want to pull something out and do some analysis on it, I mean, how would that work? Could you load a bunch of Oracle tables in there? What would you have to do in order to use some of the built-in analytical capabilities of Hadoop to do some analysis of files of that nature?
So what you do is you load data. You know, the first step is you kind of load data up. You process that data. You go through some sort of refinement, or you run some sort of algorithm out of that. You know, when you're done with that, you're going to feed the information, the results, and you're going to store the results somewhere. And the results, you can apply a schema to that. We use things like hcatalog to do so. You know, I have a person here who works with me, Melissa. You know, she deals, you know, we are users of an online CRM system, I'll just say, right? And, you know, I tell her what the report format is that I want in the end, right? Now, the way she gets to those results and the way that she gets that report done for me is up to her, right? And so really it's up to kind of her to build the algorithm. The report and the context that I'm going to use to then feed into whatever systems I'm going to use, I know what that schema is, right? And so we can use things like hcatalog to then publish results with an expected set of schema so that external systems can pick up the results of the analysis, if you will. Internally, when you're actually dealing with the data, within MapReduce, you're going to define the structure within the MapReduce job, or you're going to use hcatalog as a shared schema. Or you use things like Pig and Hive, and those are the tools you're going to use to kind of, you know, munge through the data. And, you know, Hive is naturally has a metadata schema on it as well, right? And so you're going to use the transforms and the Pig scripts, the Pig Latin, if you will, of Pig on top of Hive to kind of go through and do that analysis. Eventually, you're going to publish it to some sort of schema. And that schema, that structure, is going to be used by your analytical tools, or, you know, used within a reporting structure. Or maybe it's used by a visualization tool. You know, maybe I'm using an ODBC driver on top of it to pull the data out and pulling it into, you know, some visualization tool that has a Tableau or something like that. You know, again, it's going to come down to, you know, your explicit use case and your explicit set of tools you're trying to enable.
Yeah, and I guess this kind of speaks to that last mile, which is always the hardest one. And I think this may be a misconception in the marketplace about what you get when you work with Hadoop, even if, like, let's say they purchase or use your distribution and they're working with Hortonworks to deal with a lot of this stuff. Because a lot of these new types of big data are relatively new in terms of people analyzing them, I have to think there's a pretty steep learning curve as of this moment right now on which kinds of algorithms to do what. So, for example, I'll just give something from an attendee, and we are going a bit over time, folks. We always do, to try to get to as many questions as we can. So, speakers, if you have to drop off, just let us know. But we'll try to add a few more minutes here to get to at least a couple more of these good questions. But one of the attendees asks, can Hadoop be used to analyze image files? So let's think about facial recognition software, something that casinos have been using for years, and now you're hearing about Homeland Security using it, which I suppose can be good, can be kind of creepy. But what would you do after loading 150,000 images of faces to be able to extract some meaningful analysis from that? What kind of schema would you need to apply on the read? What would you need to do?
Yeah, it's not really on the write, right? It's on the read, and it's really all about parsing that data and using the tools to actually do that. You know, we're doing things, you know, within the next generation of Hadoop that allows you to put completely new processing paradigms on top of it beyond MapReduce. If you want to do graph processing, these sort of things, right? So there's new technologies coming out that are going to allow you to build your own processing environment if it was a custom type algorithm on, say, an image to process that, right? So there's a lot of, you know, image processing software that's out there that allows you to kind of identify faces and doing all these different things. So, you know, there's tools out there that allow you to do that, right? And so either you're going to pre-process it and then, you know, load the parse results into Hadoop, or you're going to use next generation and do that processing within Hadoop. It's not the cleanest. It's a corner use case, quite honestly. You know, I think there's a lot of other value that organizations are getting from just, you know, the straightforward business analytics stuff right now. But yeah, there's definitely tools out there to help you do those sort of things.
Okay, good. And let's get to just a couple more. We'll try to cap it at about 73 or 74, 75 minutes or so. Goodness gracious. What about XML files? What are some things you've heard about Hadoop using XML files or loading XML files and then being able to analyze them?
Yeah, I mean, a file's a file. You know, the nice thing about XML is that, you know, it has structure built into it. So it's probably going to make your processing and your parsing of the data a lot easier, quite honestly, right? You can iterate over repeated attributes. You know, there's a lot of things that you can do with XML files that are, you know, quite honestly, very nice to deal with. You know, it's a good environment because, again, I don't need to translate the XML to some relational schema just to load it. I just load it, right? The beauty of Hadoop is I don't require structure on load, right? And so there's no kind of pre-processing of the data itself. You can use that structure within whatever processing you're going to go about. And I think that's, you know, one of the benefits of XML, but then again, you have to build in the schema into the processing. Again, you can use things like the, you know, hcatalog and these sort of things to kind of aid you along in that process. It's just one more, you know, type of NoSQL database that, you know, is you know, amenable to the Hadoop world, if you will.
Right. I'll tell you what, to close us out, and folks, we'll pass all these questions on to our presenters today, so we'll be sure to get answers to you to the specific questions. Could you just, you've talked about some of these, but on this slide of Hadoop and enterprise data architectures, could you quickly explain what some of these things are, like Templeton, Scoop, Flume, et cetera? You've referenced some of these, but just a quick overview of what they are.
Yeah, you bet, and that's a whole webinar in itself. Actually, we have a webinar coming up that's going to go through kind of, you know, Apache Hadoop and what is a distribution and go through all these things. You know, so Templeton is actually part of hcatalog, and it provides a RESTful API into Hadoop. So if you know schema, which is in hcatalog, I can now use the REST interface to interact with Hadoop. WebHDFS, very similar. It provides a REST interface on top of HDFS so that you can move files or copy files or access files via REST interface. Scoop, the shortened version of SQL to Hadoop. It is basically a processing engine of which you need to build out formats and schemas that's going to allow you to move data from, say, a proprietary source into Hadoop or out of Hadoop. A lot of ETL vendors are doing this sort of work as well. Scoop's a bit lower level. It's fairly technical and complex. So you can use a lot of the ETL tools like Talent or Informatica to do a lot of similar work. Flume is a real-time, it's a streaming engine for Hadoop. If we want to write, say, a log file into Hadoop, it's not as simple as just writing the bits, right? Because, you know, I've got to have a, you know, backup. What happens if the stream gets interrupted for a minute? You know, I can't just lose a minute of data, right? It's got to be able to buffer data and that sort of thing. So Flume provides that. hcatalog is a metadata schema, provides schema for Hadoop. Pig is basically an abstraction of MapReduce. It allows you to create scripts so you don't have to understand and develop the underlying MapReduce code. It's an abstraction. It's actually an engine, a translation engine, basically, for a language called Pig Latin, which I love the name of it, right? Hive is kind of a data warehousing type utility on top of Hadoop. HBase is a low latency or a NoSQL database on top of Hadoop, right? And then there's MapReduce and HDFS. MapReduce is the processing capabilities of Hadoop across, many nodes, right, across the entire cluster. HDFS is the Hadoop file system. It stores data in triplicate across all the nodes. And Mbari is the management and monitoring console. It also allows you to install Hadoop very quickly. If I'm going to go out and deploy a 100-node cluster, what am I going to go? Secure Telnet in each one of those, install the software, configure it, go on to the next one. Well, Mbari also provides a simple installation method. So you give a bunch of IP addresses and it installs the software, tests it for you. You can do monitoring and managing of the cluster, right? This is where the IT operations guy comes in. Uzi allows you to do workflow and scheduling. You're going to have a pig script and maybe some Hive processing, and you're going to be doing some MapReduce. How do I chain all these things together and get some sort of workflow around it? HA is high availability, a key requirement of the enterprise. I need to be able to be redundant and reliable. And then finally, there's Zookeeper. Zookeeper keeps all the animals in line. So it's basically kind of a layer that allows you to pass information across different processing components and kind of understand what's going on across the entire cluster. It's really operational for Hadoop. And all those things come together to make what is a Hadoop distribution. So that's what those things are called. Each one of them is their own project with their own community of developers, with their own release cycle. We have the release cycle managers across several of these. We have the founders of several of these projects. You got to understand there are a bunch of developers, they're developing software, and they have releases, 0.92, 0.23.1, whatever it's going to be. What a distribution does, it takes all the versions that are going to work together, puts them together, and gives it to you in a single package, right? It's like it's a tarball, or it's a zip file with all the right versions, and now you can go install it, and it's going to work across all these different things. Because quite honestly, they've got to all work together, and if they're all on different release cycles, well, different versions aren't going to work with some versions, and it's the job of ourselves to do that work for you, tie it all together, and make it easy to install. And that's really what a distribution will do, and that's the business of what Hortonworks is in.
Well, that's great. And, folks, I just wanted you to see that Jim really does know what all those things are. So excellent job with that rapid-fire explanation. No, that's good stuff. And I love Pig Latin, Hadoop in the presente. Yes, indeed, Hadoop in the enterprise.
Oh, my God, Eric.
I remember it from when I was like 9. Okay, folks, upcoming topics, that this month is database, next month is cloud, December is innovators, January, hey, we've got to go right back to it. It's the biggest topic in the world of information management, big data. You can see the editorial calendar for next year. It's online at insideanalysis.com. That is where we will archive all of these webcasts, and you can go back and see any of them. We've done, gosh, just about 80 of them now. We've done, in fact, we booked 41 this year, and of course, there are only 52 weeks in a year, so it's been a busy year. Folks, this does conclude our webcast today. Speakers hang on for a quick post-conference. We'll catch up to you next time. Take care. Bye-bye.